Okay, so now we look at the chapter 9, which is a complex number. Okay, alright, so what we'll cover in this complex number, we will look at the imaginary number, and then complex number, third algebraic operation on complex number, polar form of complex number, De Moivre theorem, okay, and then Euler formula. Okay, so but we did not cover for this Euler formula. Okay, so for the part 1, we will look at the imaginary number. Okay, so what is imaginary number? Okay, let's say we have this equation, x squared equal to minus 4. Okay, so this equation basically has no real number, no real solution. Okay, so in order to solve this, okay, we will introduce the definition of imaginary number. Okay, so what is imaginary number? The imaginary number I, okay, is defined as I squared equal to minus 1. Okay, so this is the definition for the imaginary number. Okay, alright, so by using this I squared equal to minus 1, we can solve this x squared equal to minus 4. Okay, so let's say we go back to this question. Alright, so we want to solve the x, right? So of course it will be negative 4, the square root of negative 4. Okay, so if we separate it between minus 1 and 4, we can have like this. Okay, so minus 1 here is refer to the I squared, so 4I squared. Okay, so basically it is sed 4 sed I squared. Okay, so sed 4 is 2 and I squared, sed I squared is I. Okay, so we obtain this. Okay, so now let's look at this example 9.1. Okay, we want to express the following as imaginary number. Okay, so sed minus 25. So again, we separate it 25 and minus 1. Okay, so we know that minus 1 is I squared. Okay, so sed 25 is 5 and sed I squared is I. So this will be our answer. Alright, how about the second one here, B, the square root of negative 8. Alright, so ni macam mana? Okay, so we have 8, we need to multiply with minus 1 as well, so it will be sed 8 sed minus 1. Okay, sed 8, this is I squared. Okay, so we can remain plus minus sed 8 I. Okay, alright, ataupun boleh juga yang sed 8 ni sebenarnya 2 darab 4 kan. Okay, so dia akan jadi 2 darab 4, so 2 multiply with 4, yang ni I kan, so 4 tu boleh keluarkan jadi 2, so 2 sed 2I pun boleh, no problem. You can leave it like this or you can leave it like this, no problem. Okay, alright, so now that one is part 1, which is imaginary number. Let's look at the part 2, which is complex number. Okay, so what is complex number? Okay, so the definition, you can refer to the textbook definition, okay, for complex number. Okay, so if Z is a complex number, okay, so we have, let's say, Z equal to X plus IY, and Z is a complex number. Okay, the Z complex number X and Y is a real number. Okay, I is equal to sed minus 1. Okay, so from here we have from this Z equal to X plus IY. Okay, so basically X is a real part and Y is refer to the imaginary part. Betul ke sekejap ni? Imaginary part. Okay. Or sometimes people like to write as real X ataupun imaginary, real Z, which is X, and imaginary Z, which is Y, sorry. Okay, alright. Okay, so if you look at the example 9.2 here, find the real and imaginary parts of the following complex number. Okay, we have Z1 equal to 2 plus 3i. Okay, so from here, what is the real part? It is 2. Okay, this is real. Real Z1 is equal to 2. And what is the imaginary? Here. Okay, imaginary Z1 is equal to 3. Okay, alright. So now, let's look at the B. How we want to solve? 4i squared plus I minus 2i cubed. How you want to find the real and the imaginary parts? Okay, so for this case, we need to solve it first. 4i squared plus I minus 2i cubed, because we know that the definition for complex number is Z equal to X plus IY. So we need to reduce this equation into X plus IY. Okay, so kita tahu 4 I kuasa 2 is what? We know that here we have I. So I squared is minus 1. Okay, so minus 1 plus I minus 2. So I cube. What is I cube? I cube is I squared, isn't it? So minus 4 plus I minus 2I. Here is minus 1. Okay, so we'll have minus 4 plus I. So minus plus 2I. Okay, so we reduce until we obtain minus 4 plus 3I. Therefore, from here, okay, we have real Z here. Let's say we call it this Z2 lah. So real Z2 is minus 4 and imaginary Z2 is equal to 3. Okay, so from here we need to reduce until we obtain X plus IY in this form first. Then we can determine which one is our X and which one is our Y.